Let's talk databases. They're like digital warehouses for your data. Two main types exist, SQL and NoSQL. SQL databases are like organized spreadsheets. They use tables with rows and columns. Data is related and structured. NoSQL databases are different. They're more flexible. NoSQL databases store data in various ways, like documents or key value pairs. Think of it as organizing information in different containers. Why are there two types? Because different projects have different needs. SQL is great for structured data, like financial transactions. NoSQL shines with unstructured data, like social media posts. Choosing the right database is crucial. It impacts how you store, retrieve, and scale your application. Next, we'll dive deeper into each type. We'll explore popular options and their strengths. SQL databases are super common. They're reliable and well-established. Two popular choices are MySQL and PostgreSQL. MySQL is known for its simplicity and speed. It's great for web applications and managing user data. Many websites use MySQL for its ease of use. PostgreSQL is powerful and feature-rich. It's known for its data integrity and complex querying capabilities. Think of PostgreSQL when you need advanced features and reliability. Both MySQL and PostgreSQL are excellent choices. Your specific needs determine the best fit. Consider factors like data size, complexity, and performance requirements. NoSQL databases handle data differently than SQL. They offer flexibility and scalability for modern applications. Let's explore two popular NoSQL options, MongoDB and Firebase. MongoDB stores data in JSON-like documents. This format is flexible and easy to work with. MongoDB is popular for mobile apps, content management, and analytics. Firebase is a fully managed platform. It offers a real-time database. This means data updates instantly across devices. Firebase is a great choice for chat apps, collaborative tools, and real-time dashboards. NoSQL databases like MongoDB and Firebase shine when dealing with evolving data structures. They provide scalability and performance for modern applications. Section 4. Scaling up SQL versus NoSQL. Scalability is crucial. It's about handling growth. Your database should handle more users and data without slowing down. SQL databases typically scale vertically. You add more power to the same server. Think of it as upgrading your computer. NoSQL databases often scale horizontally. You add more servers to distribute the load. Imagine having multiple computers working together. The choice between SQL and NoSQL for scalability depends on your application's needs. Consider factors like data structure, growth expectations, and budget. Section 5. Choosing the right database. Real-world examples. Let's see these databases in action. Imagine building an e-commerce website. You need to store product information, user accounts, and orders. SQL is a good fit here, as it excels at structured data and relationships. Now, picture a mobile gaming app. It needs to handle millions of users, their game progress, and real-time events. NoSQL shines in this scenario, offering scalability and flexible data handling. Social media platforms often use NoSQL for handling vast amounts of unstructured data like posts, comments, and user interactions. Financial institutions might choose SQL for its reliability and ACID properties in managing transactions. Section 6. Weighing the pros and cons. SQL and NoSQL. Both SQL and NoSQL databases have their strengths and weaknesses. SQL databases excel at data integrity and consistency. They enforce relationships between tables, ensuring data accuracy. However, SQL databases can be less flexible than NoSQL when dealing with evolving data structures. They might also face challenges with massive scalability in certain scenarios. NoSQL databases offer flexibility and scalability. They handle unstructured data well and adapt to changing requirements. However, they might not provide the same level of data consistency as SQL. Section 7. Building for scale. Best practices in database design. Regardless of your choice, designing for scalability is crucial. Start with a clear understanding of your application's needs and future growth. Choose the right database type. Model your data effectively, whether using tables in SQL or documents in NoSQL. Optimize your queries for performance. Use caching mechanisms to reduce database load. Consider using a content delivery network or CDN to distribute data closer to users. Implement monitoring and performance testing to identify and address bottlenecks. Remember, building for scale is an ongoing process. Adapt and optimize your database design as your application grows.